All right. This model is discrete growth. Actually, there's one variation of this I'd like to go over. In this model, we assume that the interest is compounded annually. Sometimes your interest is compounded semi-annually or quarterly or even daily. Sometimes if you have credit cards, sometimes they compound the interest you owe them. They're not paying you. Nobody's paying you this, but you owe them. Sometimes your interest is compounded daily. So let's see what effect that has. This is the discrete model for annual compounding. With semi-annually compounding, you just have to do the following adjustment. And let's just give it first for the value for 1 year. At the end of 1 year, with semi-annually compounding, the formula is going to be this: A times 1 plus I over 2. So I over 2 is the effective interest rate for the first 6 months. So it's compounded semi-annually. I is the annually compounded. So if I were 0.5, then at the end of 6 months you would get 0.025 if it was compounded semi-annually. At the end of 1 year, though, you'd have to square this. So this is at the end of 1 year, but since it's compounded semi-annually, you have to multiply by 2. The 1 times the 2. Okay. What would this be if the annually compounded interest rate was 0.05? So this would be just, assume A is 1,000. It would be 1,000 times 1.025 squared. Okay. And what would this be worth? Anybody? Carry the decimal to 3 places. So at the end of a year, it would be worth what? John, can I impose on you again? Exactly right, Sean. Very good. Sean, I'll have to give you a bonus point for today. Now that would be if you have semi-annually compounding. Okay. What would the formula be if it was compounded quarterly? Again, this is the value after 1 year, t equals 1. So what would the formula be if it was compounded quarterly? Anybody want to take a stab? Yes, Patrick.
Divide by 4.
Okay, yeah. So you just take your A times 1 plus I divided by 4. And then what's the exponent here? 4. Because it's compounded 4 times a year. So you have to multiply this, or excuse me, you have to raise it to the 4th power. Okay. So it would be 1,000. Now this would be 1.0125 raised to the 4th power. And doing this calculation, what I get is 1,050.945. Doesn't make too much difference after 1 year, whether it's compounded annually, semi-annually, or quarterly. If the interest rate's that low, after 1 year, it's not going to make too much difference. Okay. Instead of 0.625 there, you have 0.945. Okay. If it's compounded annually, it would just be 1,050. So if it's compounded quarterly, you get about 95 extra cents a year on $1,000. Okay. What would it be if it were compounded daily? What would the formula be with daily compounding? A times what? Do we have any finance people here? 1 plus I over 365. Right, to the 365. And if A is 1,000, 1 plus I over 365. Let's see if I've got this here. Oh, actually, I just computed the total thing. So if this were compounded daily, what it would be worth is 2,718 and 28 cents. Okay. Oh, I'm sorry. No, I did the wrong. I'm looking in the wrong page. I'm sorry. I don't know that I did this. Oh, that's wrong. I'm on the wrong page. So let's figure this out. Okay, 1051. Thank you, Matthew. Okay. It gives you a little extra kick, but not that much. Yeah. That's if it's compounded daily. Okay.